So here I'd like to present another example of making a function that's in CoCoALib replace a less efficient one that's in CoCoA5. So in this particular case, the function we're going to consider is resultant. So here's the manual entry from CoCoA5. Now it turns out there's also an implementation in CoCoALib, which is almost certainly better than the one in CoCoA5. We'll see that we even have one example here that we could test it with. As I said in the previous screencast about making univariate index index available, we really should have some test cases to hand so that we could check to make things make sure that everything's working fine. So here it is in the CoCoA5 manual. The arguments it requires are two ring LMs, they're meant to be polynomials, and x, which we know that CoCoA5 doesn't have any special representation for power products or for indeterminates, so that's here marked as a ring LM. And here's an example of how we would call it. So fg and then x is a power product. Now if you have a look at the equivalent function in CoCoALib, we'll see that it's defined here. I've already looked this up in the documentation. So it takes two ring LMs, which are meant to be polynomials, and it takes a long. This is a machine integer, and that's meant to be the index of the indeterminate. So, but the result is a ring LM, the same as what we had before. So here, where for univariate index index, we had to modify slightly the final value. Here we have to modify slightly one of the arguments. So we're going to be given a ring element which we know is supposed to be representing just an indeterminate, and we need to get its index from that. So again, if we look up in the documentation, we'll find out that there is in fact a function that in CoCoALib that does that for us already. So I've already looked that up, and it's on the line where the cursor is. In fact, there are two, we see. So it returns, so is indexed with just one argument, says whether the polynomial is equal to x of I for some index I, where x of I is meant to represent an indeterminate. We actually want the second one, where it gives the same result, so it returns a Boolean, true or false, and it sets this first parameter to the corresponding index. So that's the one we actually want. So that's the one we're going to use. So let's get down to work. So go back to my shell. Now cd into where the CoCoA5 sources are, much like before. And now we already know which which files we want to modify. So the first one is going to be built-in functions CoCoALib. No, sorry, it's built-in. Oh no, I don't remember. No, it's not. Not this one. Sorry, it was built-in one-liners. Built-in one-liners CoCoALib. So we have to change three functions here, and we know that if we look down a little bit, we find the ones functions on ring LM. So we want to put it somewhere in here. And we have to do, once again, one of these CoCoALib for C5 things. So I'll just copy one of these lines here. Now, resultant takes three arguments, so we have to change the three here. Its name should be resultant, and the arguments are going to be ring LM, ring LM, ring LM. So I can cheat a bit and use auto-completion. So that's all we need to declare here. It expects to get three ring LMs, and now we have to modify CoCoALib supplement .h and .c. So where should we put this? Let's have a quick look. I'll go back to the previous file. So I put it after homog-compt. So let's try to put it in the same place here. Okay, here we have a homog-compt. And then we'll type it in here. So the result's going to be a ring-lm. Now we want resultant underscore for C5. Oops, made a mistake here. So I'll cut and paste the arguments and then modify it. So we've got 3 of these. I think the names we saw in the documentation for CoCoA5 are F, G, and X. So that's what we'll have here. And again, I'll save a copy of this line so I can put it into CoCoALib-supplement.c. CoCoALib-supplement.c. Oh, make it bigger, and then we'll have a look for homog-compt. So I say I'll try to keep the order the same. So I've copied here the function declaration. I'm now going to write the function definition. So we want to have something like return resultant of f, g, what. So we want perhaps I'll do it this way. X index, I'll call it. Now, let's go back and have a quick look at this file here. So the function I want to call, they're in the lower part here, is this version of indet. Now it puts its result actually in one of the passed parameters. So I need to have local variable x indet. I don't need to give it an initial value. We could put a comment here, will be assigned by call to is indet. And then we so first attempt would be just to say is indet x underscore indet and then x. And so if x is an indeterminate, this puts the appropriate value in x indet, and then we call resultant. But if x is some other thing, so if someone makes an incorrect call to resultant, then isIndet is going to return a Boolean false, and so we need to handle that case. Like as it's written here, we don't handle that case, so we have to say if exclamation mark is the C++ not, and remember the condition has to go in brackets, so we now want to throw an error. We can see, for example, in the function above, let's even copy this line here. We'll have to modify it, but just to save a bit of typing, I'll copy the line. Let's do CoCoA throw error. That's not so helpful. We give a message, let's say third arg must be an indet, and the function is not called homog-comp, it's called resultant. So here we don't want to give the name of the function we're actually using here. This function is supposed to be sort of invisible. We have to introduce it just to make a small amount of change from CoCoA5 to CoCoALib. And so we'll actually, the user will have called the function resultant. So we want to use that name when we give an error message. And here we give a description of what the problem was. So the third argument must be an indet, but it wasn't. And with luck that works, so let's save it. And we go back to the shell and see if it compiles. So we have to be a little bit patient here, as we saw before. This involves recompiling several files since we've changed a header file. Now we can also remember from last time that we're replacing a function that's defined in CoCoA5. So I must have, here I got an error. X index was not declared in this scope. Suggested X index. Oh, I typed the name in wrong. So here again, it helps to read a little bit the error message. So its suggested alternative was X index. So yes, should be X index, of course, and then X index here is what we wanted. Yeah, so I typed it wrong twice. Let's try compiling again. So as I was saying, while it's compiling, we can now comment out the definition that CoCoA was using. How do I find that? Let's see if I still have a CoCoA that's running. Do I? Yes. So we can do package of resultant, and it should tell me which package it's in. $mat. Okay. Also, we can now get rid of this this old CoCoA. Don't need that anymore. And we'll have a look in the packages, mat.cpkg. Let that occupy the full. So we're looking for resultant. There we go. Yes, okay, this is an obsolete manual. We'll ignore that. And here's the definition. This time, since it's short enough, I'll just comment it out by hand. So that will avoid the problem when we start CoCoA, because we won't be able to define and export this, since the name's already now for a built-in function. Let's go back to the shell. I think the compilation is finished. No more errors. That's good. Let's do it the other way around this time. So I'll do make check. So I'll let all the CoCoA tests run. I don't even know if the tests actually test the resultant function. So it's quite possible that we've not changed anything here. But anyway, it just takes a few seconds to check it. And then I'll actually start CoCoA and see if the example in the manual works. Okay, that worked. So let's start CoCoA. Since I closed it, it's forgotten that it needs to be increased. Oh yes, I can check to make sure I have the right version. And so it says here compilation time was 22:17. Clock on my computer says 22:18, so that's good. That was the version I've just compiled. We check in the manual, and let's see if we can run this example and see if it gives it the answer that it should do. So I just copy the answer there and then give it as input, and the results agree. So there's some reasonable hope that everything's working fine. So that's good. I think we can conclude this video. So I did this a bit faster than the previous one because we'd done all the steps before. The only difference here was we had to change slightly the type of one of the parameters, but the final result was the same. Some functions may have to modify slightly both a parameter and the result produced by the CoCoALib function. Anyway, I think that's all we need now, and this is a corrected version of what I did before.